we're going to go ahead and take a look at doing RBDs, rigid body dynamics, within Houdini. In addition to that, we're also going to take a look at some procedural modeling. We're going to do some switch stamp cloning, and effectively what that's going to allow us to do is going to allow us to have random dominoes go ahead and instance in within our simulation. So if we hit play, we'll deceptively have a simulation go. And I say deceptively because you would think if you're working with a domino sim that you would want the dominoes to collapse down. But more or less, I was just kind of doing a test here. And this is more or less what I got. So let's go ahead and we'll just make a new scene. Alt-N, discard and new. And we'll just start from here. So for the first bit, we're going to need a domino. So we'll hit tab and we'll create a geometry node. So within the geometry SOP, we'll pop into there and just get rid of our file node. The geometry SOP is a transform. It's just a transform node. And right now we're inside of our object. And we're going to create a box. So our box is in place, and one of the things that we'll want the box to do is rest on the ground. It's just that will be our rest state, and for that we'll do a copy parameter, and we'll actually paste that here. Now, the reason I'm going to go ahead and do this, let's go ahead and discover that. If I were to move my center either left or right, if I move it down, you can see the box is moving down, and here we're moving it up, and we got the box to rest on the grid. And these are static values. So if we were to change the height here, you get to see how the box breaks through the grid again. And we're not going to want that. So we're just going to go ahead and undo. And with that exploring, we can look at this relationship here. We can see that 1 and 0.5, the relationship is that 0.5 is half of this. So if we were to take this parameter, let's say we put 4 into here, and then put in 2, you get to see that we were able to prove that this, if we were to keep this ratio, that we can keep this on the bottom. So we'll just paste copied relative reference, and this will put an expression in. It's going to grab this channel that lives right here. And if we were to divide it by 2, well, if we click here, you get to see that it's coming up with 4. And if we divide this by 2, you get to see no matter what we do, yay, we're able to change the height here, so that's pretty useful. So now let's go ahead and change our thickness a little bit, and then our width here. And I'm not sure how large or whatever this is going to be. I haven't standardized this yet. So right now we're in an exploring phase. One thing to keep in mind, we will be working with simulation, and simulation will utilize the size. Size will affect the forces that are involved in here. So just keep that in mind. Eventually, once we understand the system, you're going to want to make sure we normalize things down so that either the size makes sense within the system, or we make corrections that will involve those changes. All right, so we have our box, and we'll just call this Domino. So we got that in place. And this could be my low res. We'll just call this low res. Domino. Okay. So we have that, and now we're going to go ahead and start working with the path. So I'm going to create another node here, and then inside the geometry we'll just create a curve, tab, curve. And I like doing things by hand. There are these shelf buttons that will allow me to create a curve quite easily, but it's good practice. So we'll right click to stop building the curve. And if you're trying to build a curve and it's not actually letting you don't have the cursor, your cursor doesn't look the same as mine. Let's say it looked like this. All you have to do is hit enter. That's going to grab you the handle tool, and then you'll be able to go ahead and draw that out. Okay, so now we have our curve. Let's go ahead and make that a NURBS curve here. So we're able to have these guys just come around. And with since we have our curve in place, we can go ahead and do an object merge, and this is going to allow us to merge in this one domino. It looks like this domino is actually here and we have access to it, but what we're working with we were just working with everything in within this section here. And we'll call this sim dominoes. So these two objects, they're independent of each other, and they're not really connected yet. They're not really being utilized one within the other. And if we jump into one system, I actually don't have access to this box, and we can see that if I were to change this down here to hide other objects. Now if we go and merge in that one object, we can utilize it within our tree. So here we'll grab let's see, low res domino, and instead of grabbing this domino here, because we might be making changes to our low res domino, we're going to actually put an output here that we'll reference to. So we'll hit a null node. This is an important concept to utilize, this null, and then we'll just call this out, geo out, or out geo. There we go. So I like out geo. So instead of referencing this, we can reference this node, which will always be the bottom of our tree, and we can put as many nodes in between as we need, and we will never have to make that change. So that's pretty useful. So here we'll go ahead and reference this and out geo, except, so now, yay, we have our low-res geometry in place within the scene. So now we'll go ahead and do a copy swap. Copy, and then we'll bring this in as our template, and then this is what we're going to copy. And then here you got to see what we're getting. The copy swap, it's going to use the, if we look at this object here, and then look at our axes, it's going to align these elements on its side. So it's essentially not using the axis that we would probably would anticipate them to use. It's actually using the z-axis, and I'm just going to go ahead and just rotate this. So if we go ahead and rotate this 90 degrees here, now this z-axis over here is going to be facing down the copy. Actually, doesn't look right. And let's go and rotate you another go. Let's see. There we go. So at least they're upright. And right now the points, they're aligning, they're trying to align to these normals here, but there aren't any normals that exist within the system. So with our curve, we're going to go ahead and create normals for our curve here. So in order to do that, we'll do a point swap. Point swap will allow us to create attributes for us. So if we hit Alt open square bracket, we can split the view. The hotkey for that again is right here under split pane top and bottom, and then Alt 8 to open up our details view. Here we have these point attributes that are sitting here and just chilling out. These are the only attributes that are on this particular curve until we add normal. So now you can see we have these normals that are in place, and if we visualize that right here, you can see that they're just pointing up. We actually want our normals to go down the curve, down the length of the curve. So in order to do that, we're going to use some vector subtraction, and we're going to utilize our point IDs. So with this NX is just grabbing our normal X, normal Y, and normal Z, and if we actually hit TX instead, it's going to grab the point position in Y, TY, and then TZ. TZ? TZ? I laughed a little weird. Okay, so here we have our TX, TY, and TZ. And what we're going to need a delta. We're going to need the difference between another point. So if we were to plug this into here and then put a sort, tab sort, we can change our point sort over here. We can grab this and do a shift. And with this is the shift will allow us, well, the sort swap will allow us to reorder our point orders in many different ways, and the shift allows us just to shift everything up by 1. So 11 will drop back here, 0 will move up, and go that way, or probably the reverse direction. So we'll bring this up by 1. So now if we look at the sort, you get to see that 0, which was here, popped back over here. 1, which was here, popped back down. So if we go ahead and bring that down, you get to see 0, 1, 2, 3. And now we have 0, 1, 2, 3. Okay, so now that we have that, what we're going to do, we're going to subtract the input from input 1 to the input to input 2. So then we'll just go tx2, and I think I might be doing my subtraction wrong, but let's see. y2, and then we'll just copy this, minus paste 2. So now if we check out the normals here, we have normals that go along the length of the curve. Yay. Cool. So now if we go back to our copy, we're going to get this this kind of weird arrangement, and that's probably because of these guys here. So now if we maybe do 90 in our Z, now we're okay. So there's a lot of playing around, and sometimes you get things right, sometimes you get things wrong, and you just keep going, and you'll be okay. So now we have these dominoes aligned along the length of the curve, and if we want more dominoes, we can easily do that with a resample. So if we go here, and let's see, we'll do, whoops, tab, resample, and then this will go into here, and then we'll change this up. We don't need so many. There we go. And you can see that first one is all jacked up as far as the orientation goes, and that's because 0 is subtracting up over here. So we're kind of having a weird issue with that. But we'll keep that as is. We can actually go ahead and delete that if we needed to, or reposition it. So with this, we'll have, I think this is pretty good. We have this setup, which is in place. And then now let's go ahead and create us a simulation. So with this, we'll just select our last node, and under rigid bodies, we're going to do a RBD fractured, and this is going to allow us to create a group for each domino, and then pass that over to our simulation. Right now, on the bottom, it says select objects for RBD fractured object, and then we'll hit enter, and now it's calculating everything. So if we go inside of our sim dominoes, it does a few things. After the copy, it passes this information to this output, or to this assemble, and the assemble is going to allow us to create a group. So if we middle click here, or let's go ahead and we'll create groups. Oop. So you got to see we have groups that are here. We don't necessarily need those, but if we go to these polygon, or excuse me, these primitive attributes, you got to see that we have for every let's turn on our groups again. If we middle click here, you got to see we have 33 primitive groups. For every 3 primitive islands that we have, we're going to get a primitive group that's here. So here it's going through all of the polygons, or all of the connected polygons. And then we're going to go all the way down, and this is going to go up to 32, and that's 33 totals. So from 0 to 32, that will equal 33 different polygon islands. Okay, so that's what this does. This guy here, this is going to allow us to keep textures associated with our object. So we're actually not going to work with this right now. And the stop import actually sends back all of our data from the simulation tree. Because right now, everything, this node right here, this node structure is just giving us our model to send to simulation. And if you can think about it as different departments, this is the modeling department. Then we're going to need to send this over to simulation department, which is this node which was created. So if we open that up, you get to see this sim dominoes brings in the geometry from sim dominoes, and that's right here, output path, and it's going object sim dominoes. Okay, so it's grabbing is grabbing the objects from the dop import 1, and we can actually change that up. We can go, if we go back up to here, grab sim dominoes, and then grab us our, maybe from here, we can go create another null, and this would be our output, and we'll call this out to dops. So this is saying, all right, instead of picking this node for our input, we'll go ahead and we'll grab this node, and this will be our runner to our simulation realm. So we'll go ahead and we'll do that. Boop. Leaving it as is will actually work, by the way. I'm just doing, just breaking up the what's going on here. So here we have that, and if we hit play now or even before, nothing's gonna happen. Whoop. Do we have gravity? Oh yeah, we do. I wasn't sure if we did or not. Either way, so if we copy this and then undo back to before, you get to see that they're both going to play, and they're both just going to work fine. If we paste this here, you get to see they both work fine. They both do the same thing. This is just more organized. You have more control over what's going on. Okay, so we have that, and then now what we're going to want a ground plane. So we'll just go ahead and click ground plane, and it's going to create a ground plane object, and it's going to import that ground plane object into the simulation, and then it's actually going to be right here on the left side of this. So now we hit play. Everything is just chilling out. They're just hanging out right now. And what we can try doing, maybe getting a wrecking ball to kind of knock these guys down. I'm just going to delete this first point right now. So we're going to do that within our sim dominoes. We'll just grab this out to dops and just shift everything down. And since this right here, right now it's using piece, this piece number, what I'm actually going to do, let's mute this, and everything's going to kind of break. And then we're going to come into our copy here, and we're going to create output groups, and then we'll just call this sim domino, and then we're going to use the point number to be our group numbers. So if we middle click here, you get to see that we have 33 primitive groups, sim domino 23, and it goes all the way down to 32, from 0 to 32. And we'll come back into here, and this object mask, we can actually keep that the same. So we'll go up a little bit, and then within our auto dop, or within the auto dop here, we're fracturing by name, and we're actually going to change this to what we just typed, sim domino, and then we're going to put a star back here. So now those elements should be in place. We should have our sim domino 0 through 15, and that's important because we're not actually working. It's kind of weird the way this this setup is happening. The modeling, we can look at this as the modeling department. The modeling department sends over the geometry, the final asset, essentially to the sim network, and the sim network takes that and references the geometry here, and then passes everything down, and everything is connected through these groups. So these groups let each section know what they're working with and where that information goes, and then once everything is done, this information gets sent back to the modeling department, which is back here, and is animated using this dop import. So if we do what we just did, we have our sim domino in place. We're going to need to make sure that this sim domino is mapped back onto these guys here. So if we go to dop import, we can just go here, and then we'll call this sim and I like to cut this just in case. If I have any doubt, we'll just call this sim domino, and then just asterisk here. So this should allow us to get our dominoes in place. Boop. And you get to see that we're getting a little movement coming in, and that's good. We actually don't need, in the end, we're going to move this into another tree altogether, but right now we're at this position. So now we're going to go ahead and create some more simulation. We're going to grab a sphere, and let's do this up here. Our run length is getting a little long, and we're going to bring our sphere up, and we're going to have this as a wrecking ball. Okay, and what I was going to do before, now I remember, I was going to delete this guy. I didn't want that there. We'll keep the wrecking ball there, and then right before this guy, we can get rid of this. Right before this guy, now that we have the groups that we were working with that I just created over here, now that we have these groups, we can actually specify. So if we go to tab delete, we can grab sim domino 1, which is the first one, and just delete that one. So now everything is pretty clean, and thanks to these groups we're able to do that. So now if we go back up, we can make this a rigid body object, just a regular rigid body, and that looks awesome. So we'll back up our animation to the beginning, first frame. Now if we hit play, this is just going to fall right there. And if we look inside of our simulation right here, the simulation tree, we have this sphere object, which is being merged in, and all of that's being passed down to the solver, and this is updating all of the rigid body stuff for these two active rigid body objects. So now, since I want this as a wrecking ball, I need a constraint. We'll go and get an RBD constraint, and then we'll just hit enter. And the constraint will be right here, and we'll just pull this up a little bit, just so we have some tension. And right now, if we hit play, this is what we're going to get. Clunk. Yeah, I usually get that wrong. So let's go ahead and just pull this up a little further. Alright, so we got that. Alright, so this is going to knock that domino, and then now these guys are just going to start toppling over. And then as the simulation gets longer, there's more to simulate, and this is going to take a little while to kind of sim, but it's doing an okay job. Okay, so this is our little simulation here, and I'm just going to save that out. Alt S, and I'm just going to go to my desktop here. We'll just call this Domino sim salabim. Okay, so we have our sim in place, but now our dominoes, or they look like playing cards now. Our dominoes are kind of boring. So then in the next section, we're going to go ahead and take a look at creating dominoes within our system, or in making them unique.